Yeah, so strictly speaking, I tried to avoid blowing things up more than actually setting things on fire, but that's a better story. All right, so anyway, right, these days, I am a systems engineer with Rackspace Managed Security, and since I got into this sort of more through the development path, I'm going to talk about how folks who are sort of vaguely familiar with, unit tests are good, but I have this code base. How do I actually get from point A to point B? So just because I only have 20 minutes here, very briefly, things that I am not going to cover here. If you want to talk to someone about the joys of working on a well-tested code base, either find me later or talk to someone. Many people will be happy to tell you. I'm not going to cover integration tests, functional tests, any of that. I'm not going to cover explicitly cover like what is a unit test, and I'm not going to get up into the sort of like intermediate level stuff for test-driven development. This is how you or someone that you're working with and mentoring can get from point like level 0 to maybe level 2. So what I am going to be covering, if automated testing is this wonderful thing, then like why don't we always do it? And we have reasons. Like we usually have reasons for things that we're not supposed to do. As I said, getting from I know the basic idea to having at least a strategy or two to look at a code base and start to just get to that where do I go? I am going to tempt the demo course and write some actual tests for you all and talk a little bit about ways to get to that intermediate level. So why don't we test? I'd like to take the approach for a lot of things that if we have things that we know are good for us, good for our hygiene, good for our code hygiene, and we're not doing it, there's usually a reason. So someone who maybe they're coming from an ops background, maybe they know how to write a script that does something, so surely testing can't be that big deal. And then they Google like how to do unit tests, and they're like, okay, so what is even the difference between a mock, a patch, a stub? Should I have been doing test-driven development from the start? What is even going on here? Other barriers may have run into things like this. You want to contribute to a code base, you don't really know how to do the testing part of it, and you get hostility back. A lot of the time, we let frustration bleed into contempt, and contempt for code and results bleed into contempt for the people who are making and writing those. This is not helpful. Guilt-driven development is not a sustainable or recommended development technique. And then sometimes we sort of get caught by our own high standards. We know that we should be aiming for a comprehensive test suite. We know that we should be aiming for this thing that's an industry best practice, but we just can't really get there, and it's big, it's intimidating, let's just not. So if you or someone that you know finds yourself in that sort of position, here is what I suggest to start out with. Write tests that document what your code does now. Don't worry about whether the code that you have is beautiful, is perfect. It has bugs, it is axiomatic. Code has bugs. But when we fix our bugs, we want to do that on purpose and not accidentally. And the place to start, the types of functions that I want you to start with is pure functions. So that means I can give it, if I call it and if you call it, no matter what's happening on the network, no matter if the database is there, no matter if someone did something funky to the global variable that it secretly or not so secretly depends on, I'm going to get the same output. So the process. Find these functions, give them some inputs, find the outputs, and document that by writing a test. So here is the part where I tempt fate a little bit. Someone where are we? Okay. So someone at some hour of the night or morning felt the need to write this little command builder script. So glitter, we always want glitter. Someone, when setting up the host nicknames, decided that there was a theme, but the spelling was inconsistent, so clearly whoever was setting this up did not hear the excellent talk yesterday on UX for developers. So this is helpful. You know, it tells us to do the things that are totally going to set it on fire, and you know, gives us the things so that we can look at it before we pass it into whatever a surely very sensitive system this is. Okay, so let's look at the code over here. We've got our main method, which our main function, which does kind of what we expect here. We've got you know, we have a nice little command line thing, and we have the output. We have the get input values, which is the interactive bit that you just saw me run. So neither of these is a pure function. If I run get input values and I type in different things on the command line, and you run it and you type in different things than I did, then we both called the same function. We're not going to get the same output. So although this is absolutely testable, this is not a good candidate for a starting point for someone who is not really sure on where to get started. But we have this nice friendly little build command method here. And there's a little bit of control flow. We can have glitter be true or false. The correct answer is always true unless you're cleaning it up, in which case, never true. And it's basically just string concatenation. So this is pretty simple. We have some inputs, we have outputs. So I've cheated a little bit here for the sake of time, and I'm going to, and I have a handful of failing tests that I've written here. So, and that's important. I like to start with failing tests because it tells me, I run the test command, and it tells me what I have to do. If it's failing, it needs attention, whether that's writing it or fixing it or something. So what I'm going to do here is I want to, because this is documenting the current state of the code, I'm going to say output equals and I'm going to assert that false equals output. I know this is going to fail. But the advantage is that the way that this works is it tells me, oh, here's the thing that you're asserting is equal to false. You are wrong. Congratulations. And we can use this and say, all right, cool. That is the expected output right now. Line length is, you know, we'll work that out later. And, oops, and I didn't change the output to be what we expect, and now we should have a passing test. All right, so we have one pass and one fewer failure. And we can, so that tests one bit of our control flow. That's with the glitter flag turned on. We can do a similar sort of deal where instead of true we're going to set false, and both of these are reasonable inputs, right? This is how we expect to see it used. we have a slightly different long string, which we can then say, yes, with this given set of inputs, this is, in fact, what I expect. You may be thinking, isn't this a little bit tautological? Like your tests pass because you made it pass. And this is kind of true. If we were, but it is still useful because what we're doing here is we're just saying, hey, this is the way that my code base works right now. And what do you know? So we have a test that if I'm going in and let's say it's unfortunately late at night and I accidentally do something like that. Oh, look, it caught my random typo. Well done, test suite. So another thing that people who are just getting started get caught up on occasionally is like, well, sometimes I want my code. Oh, sorry about that. Sometimes I want my code to throw an error, and most pretty much any framework is going to have a solution for that. PyTests there's a with pytest.raises. So if I call this with if I call this with 2 parameters instead of 3, then it'll go, oh no, I tried to run that. I got with this input, I got an error. That doesn't look like it should happen. And I can look at that and go, no, actually, that's what it should do. Crap, sorry. I'm not sure what I did there. Anyway, the idea here is that you can you can say, okay, but no, if I do that, I really do expect my code. I really do expect my code to throw an error, and having that error makes for an actual passing test suite instead of one with an error. So going back to the sort of structure of all of this, what you just saw me do is identify a pure function in a small but in a code base, find a testing framework that did what I wanted. I wrote some failing tests. I picked some reasonable inputs, whether those are reasonable for the stuff that you do want to pass to the function or the sort of reasonable errors that one might run into. And I wrote some tests that act as documentation for, okay, this is what the code currently does. Whether or not it's what we want it to do, we can think about that later, but for now, we know whether it's going to be making those changes. So, okay, this definitely is the very, very beginning of where one might want to get started. How to get better. So first thing, practice the easy stuff. If there are bits of writing unit tests that make sense to you, then go ahead and do those. And when you notice that there are certain patterns that make it easier for you to test, do more of those. This is one of the beautiful virtuous feedback loops that you get between development and testing, where testable code is often more modular code, it's more readable code. So when you have a practice of testing, it trains you to think in that way and to refactor and write in that way. And then start gearing up for the harder stuff. So testing is one of these things that seems to be more often taught in a sort of mentorship on the job, you have to, like, hey, you have some code, you have to write tests. It's not as usual to explicitly have someone have a class or training with like, hey, here's how you do that. So to get a feel for how people do that, find a code base that you like, see how they do tests. Pair with someone who knows tests well. If you have folks in test or QA in your org, they might be really good people to say, hey, I'm working on this. But when you're pairing, make sure that your goals line up because you don't want to have the person you're pairing with say, oh, we just want to get tests written for this thing as fast as possible, and well, you're going, well, I really want to understand more of how this is going, so just communicate. And once you've sort of started to wrap your brain around how this is working for you, look at some of those more advanced testing resources. You know, go and dig into what the difference is between mocks and stubs and all of those fun tools. And if you like the sort of automation and gamification approaches, and you know, we're here, we like automation, you can also add a code coverage tool to your CI to get some numbers on there. And even if you're just starting at like 10%, 10% is a whole lot better than 0%. 10% is still going to help you narrow down your search space when you are debugging. And you can set it so that it ratchets up so that, you know, even if you're starting from down here, new code at least either maintains it or slowly raises it. So thank you all for your attention. I will be happy to talk about this later, open spaces, or at the breaks.